Imagine it's all gray and cloudy. You're in your passenger seat and can't see a thing. Suddenly, you fly out of the cloud and land right on the runway. Wait, how did that happen? The pilot couldn't possibly see a thing. The system most airports use to land is called Instrument Landing System. To land safely in the right place, the plane should take a particular road. Let's project it in the air. So there are two paths for a place to fly, a vertical one and a lateral one. They cross each other at a right angle and create a crosshair in the middle. That's exactly through what the pilot has to fly to get to the point on the ground. On the instrument panel, a pilot has a display that shows if the plane is keeping the exact needed vertical and lateral path. If something is wrong, the plane can be easily adjusted according to the instrument. As soon as the plane breaks out from the clouds, the pilot can also see the ground with their own eyes and land safely. If you've ever noticed, sometimes planes get showered with water. 2 firefighting trucks stand on both sides of the plane and shoot 3,000 gallons of water on it upon arrival. This creates a beautiful water arch followed by a rainbow. This is called a water salute or a shower of affection, and it's made to, well, show the affection. It's done to greet airplanes that added a new destination to their route and just arrived for the first time. It can also be used to welcome a new plane or to honor the last flight of a particular plane. But probably the most emotional occasion is the one to farewell a retiring captain who just finished their last flight. You might think it's just a waste of water, but that's not true. There are not so many accidents happening, so fire trucks rarely use their equipment. The water salute also becomes an occasional check on the equipment to ensure that everything works properly. It might happen to you that you get the window seat, come to the plane, and there's no window. Or it's just far away. Why don't the rows in the windows match in the first place? Well, that's business. Actually, all the planes are designed so that seats and windows line up. However, when an airline buys a jet, they put in some additional seats, squeezing them closer together. This way, they have more seats, more passengers, and sell more tickets. But you get less space for your legs and probably miss out on a window. If you've ever flown, you've probably noticed those little holes on windows. An airplane window has 3 panes of plexiglass. That tiny hole is only in the one that's in the middle. It exists to regulate the huge pressure difference inside and outside the cabin. This way, the outer pane can handle the load. If the outer pane breaks, the middle one, even though there's a hole in it, will be able to keep the window intact. Also, that hole keeps the windows from fogging up. Maybe you've noticed that you always enter the plane from its left side. Firstly, the captain usually sits on that side. This way, it's easier for the captain to align the plane with the terminal jet bridge. Also, the aircraft is fueled and loaded with the baggage on the right side. If passengers come from the left, the crew can do their job undisturbed. If you've ever flown at night, you might have noticed that a plane has flashing lights on its wings. Well, in total, there's even more types of lights, so let's see what all of them are for. At the front of the plane, at mid-height of the nose wheel shrub, there are taxi and takeoff lights. Taxi lights are used when the plane is on the ground. They point in a straight line and illuminate the taxiway. The takeoff light is brighter and turns on when the plane is about to take off. Below, there are also runway turn-off lights. They light up the way at a wider angle so that the pilot can also see runway exits and turns. On either side of the plane, there are wing and engine scan lights. They're used to check if there are any damage to the wings or some ice after flying through clouds. On the bottom of the plane, there's a bright flashing red light that's called an anti-collision beacon. It's used to show that the plane is moving and it's dangerous to approach it. It should be turned on right before starting the engine and turned off only once the engine stops working. Under the wings, there are the landing lights. They're kept on until the plane reaches the height of 10,000 feet. Then, when approaching the ground, they're turned on at 10,000 feet again to make the plane more visible. Finally, the red and green lights on the wingtips are called navigation lights. There are actually 3 of them. There's another one, white, at the tail of the plane. From the pilot's perspective, the light on the right side is green, and the light on the left is red. They each have a 110-degree opening angle. The white light at the tail has the opening angle of 140 degrees. So together, they make the whole circle of 360 degrees. These lights are used so that pilots or other planes could determine in which direction the plane is flying. There are also high-intensity strobe lights. There are 3 white flashing lights, one on each wing and one at the back of the plane. They're turned on when the plane is on the runway, so that the plane is visible to other planes that might use the same runway. Finally, there are lights that illuminate the company's logo on the plane. There are 2 possible ways to descend for an airplane, the direct and the indirect descent. The instruments on the panel show the plane's altitude. Let's say it's 27,000 feet. The pilot also knows the speed, which is 300 knots. Now they have to figure out how much of the distance they have to lose to arrive. If the airport is close to sea level, they need to go down exactly 27,000 feet. If we divide 27,000 by 300, we get 90 nautical miles. This is the minimum distance needed to descend, which is a straight line from the plane to the runway. Well, imagine now that we're flying to the airport of Sucre, Bolivia. It's located 10,000 feet above sea level. Therefore, 27,000 minus 10,000 equals 17,000 feet. So, the pilot will only have to go 17,000 feet down instead of 27,000 feet. In this case, the minimum distance is smaller as well and is equal to 17,000 divided by 300, which is equal to about 57 miles instead of 90 miles. But more math comes into place because you can't descend with this speed at all times. Some of that must be lost. On average, pilots reduce their speed to 200 knots. They lose about 10 knots in 1 nautical mile. Therefore, if the speed is 300 knots and we need 200, we have to lose 100 knots. If we divide the 100 by 10 knots, we get 10 nautical miles that we'll need to reduce the speed. Well, they also account for the wind, but let's leave it behind so it doesn't get too complicated. We're not in a math class after all. So, these additional miles that are needed to lose speed are added up to the direct distance calculated. Therefore, 90 miles plus 10 miles gives you 100 miles. If we accounted for the wind, which pilots normally do, this distance also adds up to the total one. Therefore, the pilot should start the descent at 100 track miles. Every 10,000 feet, the pilot should check if they're on the right track and adjust the vertical speed accordingly until they finally land. But it might happen that the controller doesn't give permission to descend when it's already needed to start because of the traffic. This means that the pilot must keep moving forward without descending, shifting away from the descending profile. When they finally get the permission, they're already off. So, you can't reach the airport if they don't adjust. There are 2 things to do in this case. First, the plane can be pitched down. The pilot takes the plane below the descending profile as fast as possible. This way, there still might be enough space and time to slow down the airplane again before landing. Another way is to ask for more track miles. If the pilot realizes there's no way to lose enough altitude and speed to arrive, they don't fly directly to the airport. They can take some turns to increase the distance to have more time to reduce altitude and speed. And then, finally, they land.